Hello and welcome to Chapter 7 Homework, the video, with your host, Professor Naragon, as we go through the continuous probability. And again, using all those formulas that we learned in the chapter. So, starting off with question 1. We have the closing price of Schnur Sporting Goods. Common stock is uniformly distributed between $17 and $37 per share. What is the probability that the stock price will be more than $29? Okay, so we're doing our unit form, which remember that was that big old rectangle. So we're going to have A and B. Again, A is going to be the minimum, and B is going to be the maximum terms. And then we got to find the height as well, which is 1 divided by B minus A. Now, when we want to find the probability here, we're really only going to see on, since it's more than 29, is we need to take the height times the length, which is, for us, the height, which is 1 divided by 37 minus 17. And then it's going to be multiplied by the length of what we need to find, which is more than $29. So 29 ends up being our minimum in the length, and it's going to be subtracted from 37. So, taking out our calculator. So again, we're going to take 1 divided by, for me, it's going to be 37 minus 17. Again, you will have different numbers, but the same principle is still involved. Okay. Multiply by 37 minus 29. And we're looking at completely round your answer to 4 decimal. Actually got 0.4, which is actually pretty cool. Since it needs 4 decimal places. There we go. Yeah, don't forget to add the decimal places even if it's 0. Now, odds on you will have 4 decimal places. I just got lucky and only really had 0.4 on the first one. And now it's time to look at the other one, the one that says less than. So, when it's more than, we do take the highest limit. When it's less than or equal to, we're going to take the lower limit. So we're going to be using 17 this time because it's got to be less than. Basically, it's on the other half of the rectangle. Okay, so this is working the same way. Calculator. We get our height, which again was 1 divided by 37 minus 17. And now multiply it by what is our maximum value. Again, maximum value is 19 for this length, minus our minimum value, which is 17. Hit enter, and apparently I got one that I need to add extra zeros to. So, equals 0.1, or basically 10%. That's 40%, 10%. And that's really it for question 1. It's just watching out on your maximum minimums, making sure you do put the correct numbers into the formula. Okay, so again, 29 replaces our minimum value when we want to find the length for more than. When we're looking at less than, 19 replaces our maximum. So it places B in the formula. Overall, let's see what's next in store. Okay, So, customers experience technical difficulties with their internet cable service. May call an 800 number for technical support. Takes the technician between 30 seconds and 11 minutes to resolve the problem. The distribution of this support time shows the uniform distribution. Then it's going to ask, what are the values for A and B in minutes? Okay, and they want it to be 1 decimal place. So 30 seconds is actually half a minute. And we have our max at 11 minutes. Okay, so we do have our A and B right there. What is the mean time to resolve the problem? Well, to find the mean, since we only got 2 numbers, really, we add them. So 11 plus 0.5, and then divide by 2. So 5.75. Again, always make sure you check in your answers, making sure you're going step by step, understanding what's going on. Alright, now it's asking for what is the standard deviation. So y'all remember that formula? Well, let's use the calculator. So, it's going to be A plus B. Okay. And we got to make sure we square. So we got to square it. And then we're going to divide it by 12. Okay. From here, we do the square root. And this should be our standard deviation of 3.32. Oh, did I miss something? Yeah, I did. I did A plus B, didn't I? Yeah, sometimes I misread formulas. It'll be 11 minus 0.5. B minus 8. Sorry about that. Squared. Divide by 12. And now square root. So 3.03. And there we go. So yeah, sometimes, yeah, you gotta make sure you remember those formulas well. I'm trying to go a little bit from memory. Fortunately, my memory did not work very well that time, but mistakes do happen. The good thing is that if you understand the mistake and able to fix it, you're good. I noticed that I just happened to miss the formula. I did addition instead of subtraction for some reason. Guess I was still stuck on the mean. Okay, last few about this one. So what is the percentage of problems taking more than 5 minutes to resolve? Okay. So again, this is just like what we did just a second ago. We'll go on. Take our height, which is again 1 divided by our maximum of 11 minus our minimum, which is only 0.5. Okay, and then multiply it. And since we're looking at a more than 5 minutes, the 5 replaces our minimum. So we're going to take 11 minus 5. And we're going to find out. It says round your answer to 2 decimal places, but it's in percentage. So we know it's 57%, 0.14. Because again, it's going basically 4 decimal places in the calculator. And then it rounds. Since it's 2, it rounds down. 57.14. Double check. Yeah. Make sure we're still on the right case. We are still good. Watch out. Always be careful of that, because that, again, is a different format. It just wants you to do it in percentage instead of the decimal. Alright. Suppose we wish to find the middle 50% of the problem solving times. Where are the endpoints of these two times? Okay. So when we're looking at these, we're going to be trying to find basically what x is. Now, when we're looking for upper endpoints and lower endpoints, and the middle is 50%, these are going to be usually 0.25. Okay? So now we got to find out what is 25% basically. Again, lower and upper when we're dealing with the middle limits. So, in order to figure this out, take our calculator. We're going to take, again, our height, which is 1 divided by 11 minus 0.5. Alright. So this is our basically height. Now, since we're missing a variable, we know what the probability is. It's 0.25. But we're missing a variable right now, an x in our formula, because we usually multiply this by x minus the lower limit when we're looking at the low end point. And then we'll going to have to do the same for the higher. Sorry about that. So since I already know the fraction for this, we're basically going to take this number right here, and we got to do 0.25 divided by this. Now, see if it allows me to copy. Now, this is the cool thing about these calculators. So 0.25 divided by never mind. I'm just going to put it back in the parentheses then. 1 divided by 11 minus 0.5 so that ends up being 2.625. Okay, now since we're still looking for x, basically the problem would be x minus 0.5. Well, knowing that, we need to add 0.5. So it should be about 3.125. Okay, so there's our first one. Now, back to our calculator. Hopefully we have history. So we're going to do the same thing. So this 2.625, if you got history, you can go right back to it. Again, all you're looking at, calculator does not break, is taking 0.25, again, divided by our height, which was 1 divided by our upper limit minus our lower limit. Okay. Now, for the upper endpoint, endpoint 2, we have the upper number, which is 11 minus x. Okay. So, what we need to do, since it's 11 minus x, we're going to subtract from the 2.625, 11. Okay, again, gotta use a little bit of algebra. We know it's negative 8.375. That equals to a negative x. We're not done with negatives. We need a positive. So basically, times it by negative 1, it's 8.375. Okay, so the hardest part of problem 2 is going to be these endpoints. We have an x, and it's not the easiest to show on this where the x is coming from. But basically, again, we're trying to find missing limits. So we're going to always take the height. The formula is the height times the length. Well, if one of them is missing, it's all going to equal to 0.25 for these lower and upper limits. It's a quarter. So all you have to do is solve for x. Let me see. I think I used to have a program that worked. Let me see. I think it was called this. Yeah. Okay, sorry about that. Pop open the app that I have, or that I used to do. So when we're looking at the formula again, so to find the lower limit, again, we took our low limit. So this is the formula. And it would help if I can draw correctly. Oh, yay, there's a pen. Sorry, it's been a while since I've used this one. Oh. Alright, let's try this again. So, there we go. Divide by 11.5. So our upper limit minus our lower limit. And the formula usually has, when we multiply, for our low limit, we don't know this number. It's x minus 0.0, not 0.05, 0.5, our low limit. Okay? So again, this is going to equal to 0.25. Okay? So all we have to do now is solve for x. Oh, I thought it went to red. Solve for x. Oh. Okay. There we go. There we go. So solve for x. So in order to do the algebra, take point, again, 2.5, multiply by 1 minus our upper limit minus 0.5, our lower limit, basically our height. And once you solve for this, because we deal with a minus 0.5, x equals minus 0.5, we add the lower limit back. Okay? that looks more like an S. But this is the formula that ends up using. So X multiply, let's make it a dot. So 0.25 times 1 divided by 11 minus 0.5 plus 0.5. Do that. We'll make these multiplication. Okay? And then the same thing will happen. Let's see if I can just move this out. There we go. So, I don't know if that works. Nah. Anyway, hopefully your eyes are not getting messed up. So the other way will work. Same thing, equal 0.25. Oh. I like how they don't make it so easy. Let's see. There we go. So the same thing will happen when we deal with the upper limit. So instead of instead of x minus 0.5, it's now 11 minus x. And this will find the other limit. So instead of taking 0.5, we would basically take 11, we'll minus by 11, then make sure you times everything. Oh, that won't let me write. But you times everything by negative to make it positive again. Okay? Just trying to show you the formulas in use. That probably was not the best way. Maybe I'll find something that's a little bit better later on. Alright, next, question 3. Now, question 3 in itself, again, is our empirical rule. And you also have a hint here. But in order to do this, again, we have the mean of normal probability distribution is 300. Standard deviation is 8. Okay, that's going to be our big thing that we need to know. So when we look at 68%, remember that's 1 times our standard deviation. So 1 times 8. 95% is 2 times our standard deviation, which is 8 for me. And then when it's all the observations, that's 99%, are 3 times. So again, calculator. Since I already know 1 times 8 is 8, we're going to just take 300 minus 8 is 292. And plus 8 will be 308. Again, you can check. I like it when it's basically 100. Makes the addition a lot easier. So again, for now 95%, I would take 8 times 2. Then plus 300 if I want the high. So plus our mean. Or 300 minus 16 to get to 284. Okay. And then last but not least, again, you take your standard times 3 for practically all observations. And you take your mean minus 24. And then add it to the mean to get the other limit. And boom. This one's a lot more less complicated than the previous problem. As again, problem 2, I think the hardest part would be the that last one. where you guys solve for x. Alright, z-values. The z. Question 4. Now, again, if we end up repeating, I'm probably not going to be going over that problem. So right now it's been good. It's been basically different problems as we go. But again, if it repeats, that's basically, since we've already explained how to do it, y'all are going to be on your own. It's a good way for me to see how well you understand the material. Alright, so we have a normal population that has a mean of 19 and a standard deviation of 5. Compute the z-value associated with 22. Alright. So, with this, alright, so the formula that we have for z-value, remember, is going to be the number minus the mean, or mu, divided by our standard deviation. So since we have 22 here, go to our calculator, take 22 minus 19, and divide by 5, which is 0.6. And again, they want 2 decimal places, so 0.60. Again, the reason why we do 2 decimal places is for that table. So check, we're good to go. So, what proportion of the population is between 19 and 22? Round z-core computation 2 decimal places. So, when we look at this, again, we're only looking at 0.5, so basically this 0.6, since we're already halfway, we're not adding or subtracting, so the proportion, we need our z-table. So here's our z-table. Yay! And all we need to do is find 0.60. So our answer should be 0.2257. There we go. Alright. Now we're looking at what proportion of the population is less than 14. Okay, so we gotta find the z-score first. Now, I got lucky that it was 22. May have to change it. Always find your z-score first. But, so let's find our z-score. So again, you take the number minus the mean, divide it by our standard, which happens to make it 1. Wow. Now it's -1. So there's a good thing that we have to do on that. But first, let's find our probability. So 1, nothing else, is 0.3413. Now, since we want to know less than, we want to know the tail end. To find the probability, we're going to take 0.5, again, from half. Since proportionally, it's always the same. And minus 0.3413, come out to 0.1587. Okay, check. And there we go. There's question 4. Again, it's really, you're going to have that table with you basically all the time. So best thing I'm going to tell you to do is probably to print it out if you can. Print out the Z table. You can also find the Z table in other places besides your ebook, but definitely make sure you print that out. Alright. We'll do it one more time. Seems like we have another Z problem. So this one's going to ask, in New York State, the mean salary for our high school teachers in 2017 was $83,810, and with a standard deviation of $9,540. Only Alaska's mean salary was higher. Well, that's nice to know. Assume New York State salary follows a normal distribution. Okay. What percent of New York State high school teachers earned between $72,000 and $77,000? Alright, so as you can see, one thing, these are both going to be on the same half of our normal distribution. How do I know? Well, this is our mean, and both of these are below it. So that means we're going to end up subtracting these two. So let's find our Z's first. So calculate 72,000 minus our mean equals that. Divide by our standard deviation. We get to 1.23, well 1.24. Remember, round 2 decimal places. So let's go ahead and get that number on our Z table. And that was 1.24. Okay. So 1.2, 0, 1, 2, 3, 4. We're going to make sure we highlight that green. And there we go. There's one limit. Okay. Now it's going to ask for another. So now we have 77 that we have to find. So 77,000 minus our mean divided by, again, our standard. We have 0.71. Yeah. So only 0.71, 3 rounds down. So now back to the table. 0.71. Okay. So all we're going to do is subtract the 2. Again, we can't have negatives, so bigger, larger one minus the smaller one. So 0.3925 minus 0.2611. We should leave with 0.1314. Now, again, we have a percentage. So we need to convert the percentage, the decimal, to percent. So really this is 13%, 0.14. So 13.14%. And there we go. That's one good one. Now, notice this one. We're going to have one negative and one positive. Now I'm going to go back to my table because I highlighted with the same color. I'm going to change this color because this was our last number. This was the 77,000. So I don't have to redo the math on that one. We've already found the Z number. So now I just need to find this number. Now remember, this was negative. This is positive. How do I know it's positive? Again, it's higher than our mean. So 92,000 minus 83,810 divided by our standard deviation comes out to 0.86. So table 0.8, 0, 1, 2, 3, 4, 5, 6. Highlight it. We'll highlight that color. Okay. So since I have a negative and a positive, basically one on this side and one on this side, we have to add them together. So, calculator, we're going to take 0.2611 plus 0.3051. Shows us we're at 56%, 56.62%. Basically, almost 57% will fall in between these two numbers. So 56.62%. Okay. Again, a lot of steps. So it does become a little bit difficult, but that table is going to help you out so much. Just gotta find it. All right. Next, C. What percentage of New York State high school teachers earn less than $62,000? Now we love these. No limits, just less than. So we know whatever we find out for 62,000, we're going to subtract from 0.5, because again, it looks at the tail end of the curve. So calculator. Again, find the Z number. 62,000 minus our mean, which was 83,810, and then divide by our standard. Ends up being 2.29. Remember, round 2 decimal places. 6 will round up, so 2.29. Table. There's 2.2, 0, 1, 2, 3, 4, 5, 8, 9. Just gonna do that in blue too. Make sure 2.2. Yep, 9. Double check. Good. So it's gonna be 0.4890. That's the probability of that number, of that limit. But that's not what we can use. Again, we're looking at the tail end. What's less than this number? So taking 0.5 minus 0.4890, we're left with 0.011, or basically about 1.10%. Again, and once in decimal form, percentage form. So really expect, if it's doing anything like less than or more than, typically it's going to be a low percentage, because that's how Connect runs. Not always the case, but for us, it really is a low percentage. We probably won't see in New York a teacher with a salary less than 62,000. Is it a possibility? Still, yes, but highly unlikely. The most likeliness is almost half will be between 77,000 and 92,000. And again, as you can see, it's very unlikely with the 72 to 77. It's a stronger possibility than the 62, but not as strong as between 77 and 92,000. All right. That was fun. All right. So let's see. What is this one? All right. So this one is pretty much the same as question 5. Again, this time they're using commute time. So be wary of this. And definitely make sure you understand Yeah, since our only standard deviation is in New York City, and that's the normal probability that we're using, this number right here is just there just to just kind of mess with you, okay? Do not use the 25.8 minutes. That's the 30 largest U.S. cities. All we care about is New York City, because that's what's following the normal probability distribution, and that's what has the standard deviation. So whatever New York City's mean time is, that's the one you're going to use in this problem. Then you're just going to be solving it just like we did question 5. Find the z number, and then solve for these in-betweens. Looks like this one, both of them are on one side. This one is on each. Okay, and then we got a less than. Okay, try this one out. Again, if you're still struggling, just send me an email and we'll get you through it. Alright, let's see what's next. Assume the hourly cost to operate a commercial plane follows the normal distribution with a mean of 5,957 per hour and a standard deviation of 492. What is the operating cost for the lowest 5% of the airplanes? Oh, wow. These are the fun ones. Alright. So this one, we got first find the z value. Now, when we're looking at the lowest 5%, again, we're going to look at the first one that's basically above, let's see, first one above 45%. Why that? Okay, again, if you took your calculator, we know 50% minus 5% gives us 45. And since we're looking at the costs for the lowest 5% of the airplanes, okay, we're looking at basically the tail end. So another tail end, it's like less than 5%. So we're going to be looking at a number that's just a tiny bit bigger. So let's look at our table. Alright, so we're going to go find 0.45. Right here. This is going to be the first number that's going to be higher than 0.45 or 45%. I'll put that back in pink. Remove. I'm just removing these real quick so you don't have to get confused. Alright. So again, we're trying to find that lowest of the 5%. So since 0.4505 will put us in that little limit of what they want to look for, first number, we know our z number has to be 1.65. So it's 1.65. So since it's 1.65, now all we have to do is solve for x. Now again, remember we take x minus the mean divided by standard deviation. So doing our algebra, we have to do the opposite. So now, and I just forgot, 1.65. Yeah. So go ahead and put that in, 1.65. There we go. So I don't forget. So we're going to take our z number, and now, since we're solving for x, first thing we have to do is multiply by standard deviation, which is 492. Then we're going to take whatever x is, okay, and we got, since it's x minus the mu, we need to add yeah. So, 6, 7. Let's make sure on that. 6, 7. Yeah, I don't think that's... So it's looking for the lowest. Yeah. Not bad. I was thinking all in positive. But it's 1.65 since we're doing the lowest. Make sure it's a negative 1.65. I was just thinking, classic mistake. Just took it as a z-value as it is. But again, we're looking for the lowest. If it was for greater than, then we would be right on the money. So times that by 492. Then add 5957. So it should be 5,145. There we go. All right. So definitely watch out with the negatives and positives. Make sure if it's saying the lowest or a less than kind of thing, make sure that z number is negative first after you find it. If it's for greater, we would go positive. So I actually solved it first for the highest 5%. Sorry. But we're actually looking for the lowest, so it has to be negative. Okay, so a little bit more fun there. Let's see here for the most recent year availability. All right. So this looks like 90% of all students at a private university pay less than what amount? So again, they're going to look at more of a positive route. Okay, so it's the same thing that we did in question 7, except being a negative z number, it's now going to be a positive z number. So again, we're basically looking for 10%. So we have 90% of all students at private university pay less than what amount, which is 10. Which means that our area is actually going to be 40%. Because again, 100 minus 90 is 10. 50 minus 10 means 0.4. So what we're going to be looking for, actually I'm going to just go ahead and do this one for y'all. Might as well. Again. So we're at 0.4. Since we want to know how much the 90% basically pay, we're going to try and find the closest to 0.4. So again, z, and we're looking for 0.4. Close. Almost there, right here. Here's 0.4. Now, because we're looking at a different aspect, we're not looking for the tail end. We're looking at the 90%. So we're looking at the rest. We're not going to go greater than 0.4. We're going to go below. Okay? So again, when it looks for at the bulk of the chart, so 90%, 80%, basically the bulk. We're always going to go below the threshold number, the percentage. If it's looking at the tail end, so if it's looking at right here, these tails, that's when we're going to find the Z number higher than that percentage that we need. Okay? So, this one is a little bit more difficult to solve for Z numbers. But again, more practice, the better off you get. So again, if I'm looking for this all this 90%, I'm not looking at the tail, so I have to be below our threshold. So this is going to be 1.28. Put that in my calculator. All right. Now, this one right here, again, we're going to keep it positive because really it is a positive number. It's really looking for a big bulk of it. So it's on both sides of our little chart anyway, so it is going to be positive. So again, I would take this, multiply it by our standard deviation, then add our mean. So I'm coming out to 25,828. Okay. So basically what the chart showed, if we want to look at the chart here at the Z number. Again, say this is at 0.4%. They want to know everybody that pays less than 90% less than that. So that's why we're looking for X right here. We don't want to know the tail. Now, if it want to say what is the 10% or how much more does the 10% pay or something like that greater, I mean, we would have the same thing, but we would find the Z number as the next one over. Okay. Those are a little bit more difficult. I will admit to that. Okay. Takes a little bit more algebraic to figure those out. All right. All right. So it looks like question 9 is again solving like we've done before in question 7. See, we have one that's last more, in between, last between. And then as part of the report, the president, the director of communications would like you to report the length of the longest in duration of 3% per call. Okay, so basically what's greater than 3%. So again, stuff that we've already talked about. If you're having troubles with these, please let me know. I will help you with those. Let's see, 10. And again, we're dealing with the same little bit, except here is again solving for that upper 15%. So you're solving for X. So be wary. Again, we did that for questions 7 and 8. And just the last one, another Z, solving and ranges as we go. So that's basically it for this. Bulk of it is the normal distribution, just more practice on finding Z in the Z table, solving for Z, or solving for X, which again are the tougher ones. So be wary of those. And again, if you have any questions, please let me know. I will see y'all next time.